logic gates. We have looked at Boolean functions in abstract terms. In this section, we see the Boolean functions are implemented in digital computer circuits called gates. A gate is an electronic device that produces a result based on two or more input values. So what is a gate? The definition is given here. So what is a gate? A gate is an electronic device that produces a result based on two or more input values. Okay. In reality, gates consist of 1 to 6 transistors. But so in reality, the gate consists of 1 to 6 transistors. But digital designers think of them as a single unit. So in digital systems, that 1 to 6 transistors we think as a single unit. So integrated circuits contains collections of gates studied to a particular purpose. So from this slide, you will get many of the questions, Viva questions. Okay. The three simplest gates are so these are the three simplest gates. Okay, or we can say the basic gates. Those are AND, OR, and not gates. So AND gates looks like this one. So you are familiar with one previously, and related truth table is here for two input. Okay, so OR gate looks like this, related truth table. NOT gate looks like this, related to truth table. Okay. Now the correspondent directly to their respective Boolean operations, as you can see by their truth tables. Another very useful gate is called exclusive OR, or it is known as XOR gate. Now whatever the topics we are reading, that is not new to you. You are just recalling. So another very useful gate is exclusive OR gate. The output of XOR operation is true only when the values of the inputs differ. Okay. So observe for XOR 0, if there have 0 0, so output will be 0. If there have 0 1, output will be 1. If there have 0 1, output will be 1. If there have 1 1, output will be 0. Why? Can you say or can you remember? Because the logic of XOR gate is, if the both input are same, the output will be 0. So see, so here x value is 0, y value is 0. Both are same. That's why output is 0. Here x value is 1, y value is 1. Both are same. That's why the output is 0. Okay. So this is the logic of XOR gate or exclusive OR gate. Okay. So for exclusive OR gate, if we give both input same, the output will be 0. Otherwise, if they differ, if they have difference, then output will be 1. Then NAND gate and NOR gate are two very important gates. Their symbols and truth tables are shown right. NAND gate. NAND gate means, observe the symbol. NAND gate means, this means the output will be x, y bar. The function will be x, y bar. That means after doing the AND operation, you have to apply the NOT operation on the output. Okay. So the AND plus NOT, this is called NAND. If you write this one, that previously if you write NOT, that means x naught, y naught. Okay. So x naught and y naught, then this is the OR gate. This is the OR gate. So we will get x naught plus y naught is equal to x y bar. Why this is showing? Because this NAND gate is equivalent to this gate. Clear? So instead of this NAND gate, you can use this gate also. That means xy is equal to xy. Applying NAND gate, we will get xy bar. If we apply x inverse plus y inverse is equal to xy inverse. Both are same. Okay. Then x nor y. Nor means OR gate plus NOT gate. That means at first you have to do the OR operation. Then on the result of OR, you have to apply the NOT operation. So x, y, at first OR, then NOT. So x plus y bar. Okay. Then the equivalent logic circuit is the opposite. Here we have used AND gate and opposite is not OR gate. Here OR gate, not AND gate. So x bar, y bar is equal to x plus y whole bar. So you have to remember these things, equivalent circuit, the alternative equivalent circuit. Okay, clear everyone?
Yes, ma'am.
NAND and NOR are known as the universal gates. So if I ask you what are the universal gates, so universal gates will be two, NAND gate and NOR gate. These two are the universal gates because they are inexpensive to manufacture and any Boolean function can be constructed by using only NAND gate or only NOR gate. Did you understand why? So if I ask you that why NAND gate and NOR gate are universal, not only for this course, okay? So you have to remember this because these are the basic things you have to remember for your graduation comprehensive viva also. Okay? So NAND gate and NOR gate are known as the universal gates. Why universal gate? Because by using NAND gate or only using NOR gate, we can simplify the Boolean function. Any Boolean function we can simplify. So observe x, where do we x input? This is not x naught, this is x. Okay? Then x bar. So this is x input, y input, x and y. So we are doing x and y. After that we are applying NOT. So as the output we will get here xy bar. Okay, xy bar. If we give input on this circuit, so double bar. Double bar means so OR gate. So you have to remember the symbols also. X gate or Y gate. So X or Y. So X gate we get X bar. Y gate we get Y bar. X bar, Y bar, and gate we are giving input. So X bar, Y bar, whole bar is equal to. So from applying the formula from the law, which law is applied here? Xy is equal to x plus y. Who can say? Which law? This is your homework. You will find out that which law is applied here. Okay, is equal to x plus y. I will not say, otherwise you cannot remember. I have said you to remember all the law. Gate can have multiple inputs and more than one output. Multiple inputs, more than one output. Let's see. A second output can be provided for the complement of the operation. So a second output can be provided for the complement of the operation. We will see more of this later. Okay, let's see. Now the topics we are reading, the digital components. The main thing to remember is that combinations of Gates implement Boolean function. The circuit below implements the Boolean function x y z equal to x plus y inverse z. So let's draw the circuit diagram for this function x plus y inverse z. So observe what is the main logic gates here. Main logic gates here. This middle one is this plus sign. So for plus sign, the related logic gate is OR gate. So we have drawn the, at first we have to draw the OR gate. At first we draw the OR gate. Then one input is x. So I am giving one input x. Another input is y inverse z. So we have to solve y inverse z. So for y inverse we have to use y not bar. Then we will get here y inverse. Okay. Then z. We have to do y inverse and z. So use here AND operation. So here y inverse, there z. So we get y inverse z. So y inverse z and here x. So after that we will get output x plus y inverse z. So we simplify our Boolean expression so that we can create the simpler circuit. So why we simplify the Boolean expression? The purpose to simplify the Boolean expression is to create the simpler circuit. Now combinational circuit, we have designed a circuit that implements the Boolean function x, y, z is equal to x plus y inverse z. This circuit is an example of combinational logic circuit. Why this is a combinational logic circuit? Combinational logic circuits produce a specified output almost at the instant when the input values are applied. So in a later section, we will explore the circuits where this is not the case. Okay, so let's see. So combinational logic circuits gives us many useful devices. One of the simplest is the half adder. So if I ask you, the question is, the Viva question is from here, that if I ask you that where we can apply the combinational logic circuit, so answer will be half adder. Already all of we have read half adder, full adder, multiplexer, is not it? সবাই আমরা পড়েছি না FEDS এ? All of we read. Those who are my FEDS student, I can say you have read. Obviously, we have read half adder. Yes, we have read half adder, full adder, multiplexer. Okay, so in this half adder we use the combinational logic circuit, which find the sum of 2 bits. So what is the work of half adder? The work of half adder is to find out the sum of 2 bits. So you have to read like this way for preparing yourself for the Viva. We can gain some insight as to the construction of a half adder by looking at its truth table. So shown at the right side. So see at the right side, input is this one. So sum 0 plus 0 0 1 1. So here is also carry 0 carry 0 carry 0 1 plus 1 0 carry 1. Okay, so this is the table of combinational circuit. Okay, the example is half adder. Now see the carry, how the carry is coming. This is the circuit of half adder. You have to remember, if I say that draw the circuit of half adder, draw the logical circuit of half adder, so you have to draw it. So as we see, the sum can be founded by XOR, using XOR. This is the XOR operation, and the carry using the AND operation. Now combinational circuit, we can change our half adder into the full adder. For full adder, okay, by including gates. So for full adder, how we can make a half adder to full adder? By including the more logic gates. Okay, So for processing the carry bit, then the truth table for a full adder is shown on the right side. Observe, so x, y, there is x, there is y, this is carry in, these are the carry in, and this is the sum, and this is the carry out. Okay. So this is the how can we change the half adder shown below to make it a full adder. This is the circuit. So previous this was the half adder. This is full adder completed circuit. Okay. So you have to remember this full adder circuit. And the truth table. Now, just as we combine half adders to make a full adders can connected in series. So full adder can connected in series combination. The carry bit ripples. So already we read ripples factor. Can anyone remember ripples factor from FEDS? What is ripples factor? Ripples bit. I will not say. After going home you will search it, recall your memory. Okay, the carry bit ripples from one adder to the next, hence the configuration is called a ripple carry adder. So today's system employ more efficient adders. That means nowadays we use more efficient adders. So what was the purpose of adder? Can you remember the purpose of adder was doing the sum, addition. Okay, so this is the figure of a adder. That all the adders, half adders, full FA means full adder. So 1, 2, here we can see 3 full adders or many dot is given here. That means many, 15, C15. That means maybe 15, C1, first adder, C2. Second adder, carry 1, carry 2, carry 15. That means as much as adders you can use, but that should be connected in series. So from here also some Viva questions may come that if I want to connect more than one full adder, so what will be the connection type? The connection type will be series connection, not parallel. Okay? Because this is a adder. This is adder. Adder is always in series connection. If you add something in parallel, that will be divided. Now decoders are another important type of combinational circuit. Decoders, encoder, decoders. We also read little bits of about encoder and decoder in digital electronics. Among other things, they are useful in selecting a memory location according a binary value placed on the address lines of a memory bus. Address decoders with n inputs can select any of 2 to the power n location. That means number of inputs is n, so location will be 2 to the power n. So if your input is 2, so the location will be 2 to the power n. So mandate 2 to the power 2, that means 4. Okay, this is a block diagram for a decoder. This is a block diagram. This is the input of n and output will be 2 to the power n. Okay, this is called decoder. That means number of input, if the number of input will be n, the number of output will be 2 to the power n. This is the work of decoder. That means in decoder, the number of outputs will be much more than the number of inputs, and that is the ratio is 2 to the power n. N is 2 to the power n. Now that is what a 2 to 4 decoder looks like on the inside. So this is the decoder circuit. You have to remember the decoder circuit. So if you observe, there have 1, 2, 2, 3, 4. 4 AND gate. So X input. So observe X input at first going to the AND gate. Then X is becoming here not. Then this X not is going to this AND gate and this AND gate. Observe line by line. Then another input of this first AND gate is, one input is X, another input observe Y directly. Then for second AND gate, one input is X, another input is Y naught. So observe X, Y naught. For third AND gate, another input, observe my cursor. First input is, so here we got not bar, that means X naught. Then another input is Y, X naught Y, X naught Y. Okay. Then for fourth AND gate, first input is coming from, this is not X naught, second input is Y naught. See, all the combinations are unique because number of input is 2, but number of output is 4. So if n is 2, so observe, is it matching? My input of n is 2. So what should be the output based on the decoder definition? 2 to the power n. So 2 to the power 2 is equal to 4. So 2 input, 4 output. If there have 3 input, so how many numbers of output we will get for decoder? I will ask you in the Viva. Hello? Can you hear me, anyone?
Yes, ma'am.
Yes, ma'am, we are getting.
In the decoder, if I give 3 inputs, so what will be the number of output?
9, ma'am.
9.
8.
Yes. 2 to the power 3. That means 8. Because we said if n is input, the output will be 2 to the power n. So the value of n is, if value of n is 3, so value of output will be 2 to the power 3 is equal to 8. Okay. So now observe, if x equal to 0 and y equal to 1. So now you will find out for each and every line what will be the output. If x equal to 0, y equal to 1, what will be the first AND gate output? Tell me. What will be the first output? This one. If x equal to 0 and y equal to 1, what will be the first output?
0.
0, because 0 and 1 is equal to 0. And second output? Second output?
0.
X, y bar. Y bar means 1 will be 0. So 0 and 0 means 0. Third output? Third output? X bar, that means 0 bar is equal to 1 and y is equal to 1. Very good. 1 and 1 is equal to 1. Fourth output? So x 0, 0 become 1 and 1 becomes 0. So fourth output will be 0. Okay, those who are participating, very good, that means you are understanding. Those who are not understanding, that means you are not participating, you are not concentrating. So that will be your fault if you cannot do well in the 5 or other season exam. Okay, so now this is the multiplexer. Till now we read decoder. Now we are reading multiplexer. Okay. So what is a multiplexer? So see the block diagram. In the block diagram we can see there have input 1, 2, 3, 4 input and 1 output and another 2 extra line, that is control line. A multiplexer does just the opposite of a decoder. So what was the function of a decoder? The function of decoder was, if you give n number of input, so we will get 2 to the power n number of output. That means less input, many output. Okay. We also read multiplexer and decoder in the FEDS subject also. So, what is the characteristics of decoder? The characteristics of decoder is less input, more output. And the characteristics of multiplexer is just opposite. More input, less output. Okay? Clear?
Yes.
Yes, ma'am.
Today I asked this question in the comprehensive Viva, that what is the characteristics of the multiplexer. Comprehensive Viva, you know what is comprehensive Viva?
Yes, ma'am.
Comprehensive Viva means before graduation you have to give a Viva for overall the course subject, for all the course subjects. Okay, so these topics, whatever the topics you will read, try to not memorize, try to understand from your heart so that you will never forget that. Got my point? I am telling you for permanently doing the good results, not only for this course. Because your target is not only for passing this course, I think. Your target is to build a complete, successful career, is not it?
Yes, ma'am.
So is not these topics are very interesting? These are very interesting topics.
Yes, ma'am.
Just you have to, after finishing the lecture, you have to read it by yourself little bit, so that you can understand everything. And you have to be little bit sincere that what is happening here and what is happening to the others. And sequence by sequence you have to remember, so that you can get the sequence. Okay. The multiplexer is, so now read the multiplexer. What are the attributes? A particular, so multiplexer does opposite of the decoder. It selects a single output from several inputs. The particular input choose for output is determined by the value of the multiplexer's control line. So this is the control line. So what is the work of control line? You will get answer from here. The particular input choose for output is determined by the value of the multiplexer control line. That means from which input the output will be taken, that will be chosen by the value of the control line. Got my point? See, if I ask you what is the work of control line, now I hope you can explain it. To be able to select among n inputs and log to n. So what is the function of log to n? Log to n, that means this function is used to reduce, make the half, almost less than the half of the input that will create. Okay, so the function is log to n. So to be able to select among n inputs and log to n control lines are needed. Now this is the circuit diagram of 4 to 1 multiplexer. So if you put the value of log to n, that means if you put the value in the calculator log to 4, so you will get the answer is 1. Okay, so by this way you can find out. That's why previously we said that the human thinking can be expressed as Boolean, algebra and also the mathematical equations. Okay. Now did you understand how we can express by the mathematical equations? Then that is what 4 to 1 multiplexer looks like inside. So you have to remember this slide, this circuit. All of you at home, you will draw this circuit and you will practice without seeing. Now combinational circuit, this cipher shifter moves the bits. So another combinational circuit we are reading, that is shifter. Shift, that means that will shift. We read shift left and shift right operation, is not it? আমরা shift left shift right operation পড়েছি না? So that will do this work. So this shifter moves the bits of a nibble one position to the left or right. So this is the work of shifter. So if I ask you the work of shifter, so you have to read this slide. Okay. And these are I means input. These are the control. These are the control line S, and these are the output. So you have to remember this one. So that's all for today. Till the shifter combinational circuit. Next day we will read the sequential circuit. Okay.
Yes, ma'am.
So now I would like to take your attendance.